Hi, good morning. In this lecture, we will learn about shape factor. Shape factor of a section. Already we have learned about plastic modulus as well as section modulus. So shape factor is nothing but shape factor S equal to it's the ratio of plastic modulus to section modulus, that is ZP by ZE. So already we know how to find plastic modulus for a section and how to find elastic modulus or section modulus of a section. So that ratio ZP by ZE is called shape factor of a particular section. Now we will see shape factor for different sections. Okay, first we will see for rectangular section. Shape factor for rectangular section. Okay, so if you take a rectangle of dimensions B and D, so what is the plastic modulus for this rectangle? Already we know that is BD square by 4. And what is the section modulus for this rectangle? BD square by 6. How? I by y max. I is BD cube by 12 divided by y max is D by 2. So BD square by 6 is the section modulus for rectangle and ZP is BD square by 4. This is we have done already earlier lectures. So equal area axis, top area B into D by 2 and center distance D by 4. Similarly bottom, if you add those two things, we get BD square by 4. That is plastic modulus for rectangular section and section modulus for this section is BD square by 6. The ratio now S equal to BD square by 4 divided by BD square by 6, that equal to 1 by 4 into 6 by 1, that equal to 1.5. So shape factor for this rectangle is 1.5. Now we will see for circular section. Shape factor for circular section. Oh, what is the ZP for circular section? ZP equal to circular section of diameter D. What is ZP? Already we have learnt about plastic modulus for this circular section, that is equal area axis. This area pi d square by 8 into central distance here to here 2d by 3 pi into, because similarly bottom area also there, so twice of that, so we get pi and pi gets cancelled, d cube here 2 and 4 times and this 2, that means 2 times 6, so d cube by 6, dq by 6 is plastic modulus for this circle. What is section modulus? ZE. ZE is moment of inertia divided by y max. Moment of inertia is pi d power 4 by 64. Y max is d by 2, that equal to pi d cube by 32. That is section modulus or elastic modulus. So we know plastic modulus of the circle d cube by 6 and elastic modulus as pi d cube by 32. So the ratio is a factor now. What is that ratio? Zp by Za. So that is d cube by 6 divided by pi d cube by 32, that equal to, so d cube gets cancelled. So 1 by 6 into 32 by pi. 32 divided by pi. That equal to 16 by 3 pi. So section modulus is this much, plastic modulus is this much. So say factor is 16 by 3 pi. That's in numerical, that is 16 divided by 3 pi. It is 1.698. 1.698. So say factor for this circular section is 1.698. Next, we will see say factor for some other section like some T section. Okay. So T section. Say factor for T section of this one. Hundred, 10. This is 100. This is 10. Okay, this is the T section. So to find the say factor S, we need to find ZP as well as ZE. It means plastic modulus as well as section modulus or elastic modulus. So first we will find ZP. So ZP equal to, so here what is total area? 100 into 10 and this is also 10 into 100, total 2000. So equal area axis will be here. This is equal area axis. Equal area axis. So now ZP equal to, already we know that, so 100 into 10 into 10 by 2, that is 5, plus this is 10 into 100 into 100 by 2, that is 50. So that equal to 55,000 mm cube. That is ZP. So now what is ZE? Elastic modulus. To find elastic modulus, we need to find neutral axis. That means centroid. That means y bar. So y bar equal to, let us take this as 1, this as 2. a1 by 1 plus a2 by 2 by a1 plus a2. That is a1 by 1 means 100 into 10. This is a1. y1 means 100 plus 10 by 2. That means 105 plus a2 10 into 100. y2 100 by 2, that is 50, whole divided by a1 plus a2. Total area 2000. That is y bar. So that will be 100 into 10 into 105 plus 10 into 100 into 50 divided by 2000. 77.5 from bottom. So this is somewhere here. This is neutral axis. So this neutral axis is from bottom, it is 77.5, and from top it is total 110. 110 minus 77.5 is 32.5. Okay. So now, to get ZE, we need to find moment of inertia I. I equal to first rectangle moment of inertia is 100 into 10 cube by 12 plus, to shift that neutral axis from here to here, I mean that the self moment of inertia is 100 into 10 cube by 12, but we need to find moment of inertia about this neutral axis. So the shift is according to parallaxis theorem. We need to add area into h bar square. That area is 100 into 10. H bar is from bottom, it is y1 is 105. This is 105 minus y1 minus y bar 77.5 square plus second rectangle is this one completely. Okay. So that is 10 into 100 cube by 12 plus, similarly according as per this, here we have added this term h bar square. So here also we need to add area into h bar square. So this area, this rectangle, complete second rectangle area is 10 into 100. Its h bar is y2 minus y bar. y2 is 50. Yeah, this one 50 minus y bar 77.5 whole square. So this is I, moment of inertia of this T section. So that is 100 into 10 cube by 12 plus the 1000 into 105 minus 77.5 square plus 10 into 100 cube by 12 plus 1000 into, that is 27.5 square. That is 2.35 into 10 power 6 mm power 4. Now, what is ZE? ZE equal to I by y max. That equal to I is 2.35 into 10 power 6. By y max is 77.5. So, what is ZE now? 30,376. Okay, mm cube. So this 55,000 is plastic modulus and elastic modulus is 30,376. So the self factor S is ZP by ZE, that equal to 55,000 divided by 30,376, that equal to 1.81. No units for self factor. So procedure is very simple. First, based on equal area axis. Equal area axis means what? We need to split this T section area into two equal sub areas. That means total 2000 area above this equal area axis 1000 area is there, and below that equal area axis 1000 area is there. So after that, after splitting that, we need to take moment of areas for all splitted parts. So this one part and this complete one part. So moment of areas, that is ZP, plastic modulus. Already we learned that in previous lectures. So after getting that ZP, then we need to find ZE. To find ZE, we need to find moment of inertia as well as Ymax. So first Y bar, that means standard distance from base bottom. How much we need to find? For that, area 1 100 into 10, Y1 105, area 2 10 into 100, Y2 50, that is 100 by 2, by total area 2000, that is Y bar. So that is 77.5. That means centroid is 77.5 mm from base, and total is 110, that's why this is 32.5. So now we can find I very easily. 100 into 10 cube by 12 plus 100 into 10 area, and shifting that 105 is y1 minus y bar square plus self moment of inertia of the second rectangle is 10 into 100 cube by 12 plus 10 into 100 is the area, y to 50 minus y bar 77.5 whole square. So we'll get this much I. Y max already we know 77.5. So ZE will be 30,376. Now S is 1.81. Then we will find say factor for diamond section. Okay. Diamond section. Okay. So let us take this A and this A. For this, already we have learned how to find ZP. ZP is how much? This is equal axis. Neutral axis also same. This only because it is because of symmetry. So this is A root 2. This height will be A by root 2. This also A by root 2. So what's the area of this triangle? Half into base A root 2 into height A by root 2, and central distance about equal area axis is 1/3 of A by root 2. Same for bottom triangle also. So we can multiply with 2 like this. Now that is equal to this 2 and this 2 gets cancelled. This root 2 and this root 2 go away. So A cube by 3 root 2. That is ZP for plastic modulus for diamond, and moment of inertia. What is elastic modulus? Elastic modulus is moment of inertia divided by Y max. I by Y max. What is I? I we know for this triangle about base BH cube by 12, and this also for this also BH cube by 12. So B is A root 2, H is a by root 2 cube by 12. So twice of that because two triangles. This is I and y max is a by root 2. A by root 2. So that equal to see 2 6 times and this a by root 2 whole cube by a by root 2, that is a root 2 a by root 2 square by 6, that equal to a square by 2, here 2 root 2, so a cube root 2 by here 2 and 6 12, or that equal to a cube by 6 root 2, a cube by 6 root 2, that is elastic modulus. Now S equal to ZP by ZA, that means a cube by 3 root 2 divided by a cube by 6 root 2, that equal to 1 by 3 root 2 into 6 root 2 by 1, that equal to 2. So safe factor for diamond is 2. So far we have seen for rectangle, circle, T-section and diamond. Out of all these four, so 2 is the highest safe factor. So highest safe factor is for diamond and least is for, so far we have observed 1.5 for rectangle, 1.6 something for circular, 1.8 something for T-section. Okay, so this diamond section is having highest safe factor as 2. So we will see for I section also. Now we will see safe factor for I section. So for this I section, what is ZP? ZP equal to, so we know equilibrium axis is almost middle here. So ZP equal to, this is 50 and this is 50. So 100 into 10 into 50 plus 5 55 plus this one is 10 into 50 into 25 is the central distance, and similarly bottom also, so 2 times of that. So ZP equal to 100 into 10 into 55 plus 10 into 50 into 25, right close, into 2, 135 into 10 cube mm cube. That is ZP. What is ZE? I by Y max. I is nothing but here this total width is 100 into total depth is 120 cube minus this width 100 minus 90 into this is 100 cube divided by 12. This is moment of inertia. So total box, outer box minus this moment of inertia for these two shapes. That is width is 90, 100 is the depth. So this is the shortcut for finding moment of inertia for I section, symmetrical I section, divided by y max is here. This is this equilibrium axis and neutral axis both are same for this section. So y max is 50 plus 10, that is 60. Here also 60. So y max is 60. That equal to 100 into 120 cube minus 90 into 100 cube divided by 12 divided by 60. 115 into 10 cube millimeter. So S equal to 135 into 10 cube by 115 into 10 cube, that equal to 135 by 115, 1.17. So for I section we got least safe factor 1.17, highest for diamond section 2 we got, for rectangle section we got 1.5, and for circular section 16 by 3 pi that is around 1.6 something, and for T section 1.8 something we got. So all 5 sections we have solved this safe factor. So you can find safe factor for any cross section. Okay, this will be very important in plastic analysis. We will see the physical importance also in some other lecture. So we'll meet in next lecture. Okay.